Hey folks, this lesson is to get ready for your upcoming Integrated Math 1 final. This is our second review worksheet that mimics your final, types of questions that go on your final, okay? All right, so state which form, whether it's standard form, point-slope form, slope-intercept form, or neither or none, each equation is in, okay? So here we go. So here's our review of standard form, point-slope form, and all that stuff. So right here, point-slope form is y minus some number equals some number times x minus some number. Okay, no, not that one, not that one. No, this one right here. Here's y minus a minus 5 equals, and there's a little hidden -1 right there, times x minus a minus 1. This one's point-slope form right there, okay? Slope-intercept form is y equals mx plus b. Here, this one, y equals mx plus b, okay? Standard form is ax plus by equals a number. So here's ax plus by equals some number. This one looks like it's in standard form, but you can't have that y right there. It'd have to go over here with that one. So this one's standard, neither, slope-intercept form, point-slope form. Okay, that's what all those are in. Okay. All right. I know I go kind of fast. I'm sorry. Please just click on the video just anywhere on the screen, and it pauses it. So if I go too fast, just click anywhere. And of course, you can always replay it or rewind it and go down over here and grab that little cursor and pull it back, and you can hear what I'm saying all over again. Okay, so here we go. So let's solve this guy. Okay. All right. So before I do, I'm going to change this mixed number right here into an improper fraction. So we do 5 times 2 plus 1. 5 times 2 is 10. 10 plus 1 is 11. So you'll see that over here. Okay, and when I do that over here, that's my new numerator. So 11 over 5. All right, and then what we do is we get rid of those fraction parts by multiplying by the denominator. 5 times 5 times 5. Okay, so that's what we're going to do, okay? And then what happens is it cancels all that stuff out, and then we just have a simple middle school problem. So we just add 15 to both sides, and we get 26. Okay, so let's try another one here. So here, you guys, there's a couple ways to do this. I don't want to confuse you too much. I think the easiest way, and the way most people are going to do, is do 15 times this, 15 times this. It's called the distributive property. We just put that 15 through. And then 3 goes into 15 5 times, and so 5x plus 45 equals 60. So we'll subtract 45 from both sides, and we get 15. 5x equals 15, so x must be 3 on that one, okay? All right, let's see. Okay, on this one, again, I'm going to distribute this 3 through, okay, and we're going to shade it on this number line, so it's going to go this way or this way. It's going to be a closed circle because you got the equals bar, so we're going to fill in the circle, so that means we're including our solution right here. Okay, let's put the 3 through, so 3p plus 3, so that's what I'm going to do, is distribute that 3 through. Okay, and then subtract 3 and then divide by 3, and we get p is less than or equal to 5. Okay, again, we're doing a closed circle because we have that equals bar right there, so closed circle. If that equals bar wasn't there, it would be an open circle, not shaded circle. I have a couple of those coming up, like this one, okay? All right, okay, we don't like that fraction, so let's multiply both sides by 4. Okay, 4 times -1 is -4. On the right-hand side, the 4's cancel. So when we subtract 12, just be careful, you guys. We got -4. We have -4, sorry. -4, and we're going to subtract 12. Is going to get us -16 when we do that. And it's going to be an open circle right here. All right, and be careful, you guys. I don't like having the variable on the left-hand side. See how the x is, I'm sorry, on the right-hand side. I'm sorry. So I'm going to put it over here and flip that over here. Notice how the inequality is pointing towards the x. So when I flip it the other way, the inequality flips around the other way. And as long as you have the variable on the left, excuse me, then that's the way you shade. Okay, if your variable's on the right, you shade in the opposite direction. Okay, all right, both of these are open circles. So what I'm going to do on this one here is I'm going to go plus 2, and I'm going to get rid of that denominator, go times 8 times 8. So let's do that. Okay, you can hear Lucy running around with the ball. So she took out the squeaker, so you don't hear it squeaking, but here she is. She's wanting to play right now. So just a minute, let me throw it. Okay. Well, I don't know if you can hear in the background or not. Negative 8 plus 2 is negative 6, and then when you cancel, you get m greater than 8. Now, typically, you guys, almost always, for now anyways, not until we get into IM3, if you see that word or, then it's a graph with two lines, two pieces shaded in opposite directions, okay? Almost always you see the word or, your graph's going to look something like that. Excuse me. I've been fighting this cold for the last month, golly. Okay, here's another or statement, so it's going to go in opposite directions. All right, so what I'm going to do on these guys here is I'm going to go minus 3, minus 3. I'm going to go plus 10, plus 10. And when I do that, okay, now be careful. Now when we go, when we're adding and subtracting negatives, you guys, negative 37 minus 3 is negative 40. These guys will cancel. Negative 25 plus 10 is negative 15. Okay, so just be careful on that. And then divide, and we get that. Now remember, when we divide by a negative, this is where it gets a little tricky right here. I divided by the negative 10, and it flipped that inequality. Okay, this one we divided by positive 3, so the inequality stayed in that direction. All right, so here I'm going to cancel these, and negative divided by negative is a positive 4. Okay, so I'm here. All right, now I like to do the smaller number on the left-hand side. So I'm going to put this one first over on here, and this one over here. Okay, that way the inequalities tell me, excuse me, which way to shade. Notice we have the open circle on the 4. So here's my open circle right here, and a closed circle on the negative 5, because we have the equals bar right there. Okay. All right. So write an equation in slope-intercept form of a line that goes through 2, 1, and 3, 4. Slope-intercept form is y equals mx plus b. So that means we got to know the slope. Okay. So what I'm going to do is let me back up here. So this is my. I thought I labeled this. This is x1 y1. This is x2 y2. So remember, the y's go on top because they only have one leg to them. The x's go on bottom because they have two legs, and they're stronger and they can hold up the y's better. The y's wouldn't hold up the x's. And it's a dumb gimmick that's not true, but it makes it helps me remember. So I'm going to go the second y minus the first y on top over the second x minus the first x on bottom. So here it is right there. So I get 3. Now it says slope-intercept form. So we know this so far, y equals 3x plus b. To get b, you can substitute in. It doesn't matter. I'm going to do both of them on this one. I'm going to substitute in that for x and that for y. And then on the other one, I'll substitute in that for x and that for y right here, and then solve for b. And then whatever b is, then y equals 3x plus whatever we get for that b right there. Okay, so there that is. I'm doing the 1 comma 2, where 2 is the x and 1 is the y. Okay, so subtract and we get 5 right there. So there's our equation right there. If we put the, oh, I guess I didn't do that. Golly, I thought I did. If I did, though, let's do that real quick. Let's put in the 4. So I get 4 equals 3 times 3, because x is 3, I'm putting in the other point, plus b. Okay, and then I won't get too crazy, but 3 times 3 is 9, and when we subtract 9 on both sides, so I do minus 9 minus 9, 4 minus 9 still gives me negative 5. So we'd still get y equals 3x minus 5. Okay, hope that makes sense. Okay, so for f of x, which is just negative 7x plus 2, what's the value for which of x that makes f of x equal to 58? Okay, well, if f of x equals 58, let's just set it equal to 58 and solve for x. So we'll subtract 2 from both sides, and 7 times 8 is 56, so negative 7 times 8 is also negative 56 right there. So we get x equals negative 8, okay? All right, here you go, Lucy. In a day, John travels 5 times the sum of the number of miles Julie travels in 3. So the sum of the number of miles Julie travels in 3. So think of that part first. The sum of the number Julie travels in 3. So we'll let x be Julie, and we're going to add 3 to that. So the sum would be x plus 3 for Julie. Okay, so let's do that real quick, okay? And then it says John is 5 times that. So we'll multiply that times 5 is John. So Julie's going to be X. And then John is 5 times the sum of hers plus 3. So it says together, we're going to add those together and get 75. Okay, so let's put in those expressions right there and distribute that 5 through. Combine 5x and x is 6x. And then subtract that 15 from both sides. And so we get x equals 10. Now let's answer the question. I always ask my students, 10 what? 10 tires, 10 babies, 10 centimeters, 10 feet, 10 what? What does X stand for? So this is the number of miles. So Julie traveled 10 miles because she's X, and then John travels 5 times 10 plus 3, or 5 times 13, which is 65. Okay, so there's the answers right there. Okay. All right, we're almost done, you guys. Okay, the graph to the right shows Scott's distance from home over time. Describe what might happen at each lettered segment right here, okay? All right, so John's either walking or running or stopping, okay? Or Scott, sorry. So it looks like since this is less steep, I'm going to consider John walking. And this is more steep, he's going faster. Because right here, this is the time, and this is the distance right here. So the steeper that goes, the faster he must be going to go a greater distance. Looks like he took a break right here, lunch break, or he's visiting with people at the office or something like that. So the A is walking, B is running, and C is stopping, taking a break, a coffee break or a lunch break or whatever. Okay, so here's the ordered pairs. So state the domain. The domain is all the X numbers. So here's the domain, -7, -3, 0, 2, 5. The range is all the Y numbers. So the range is, oops, let me grab that. So the range is this number, 7, 4, 8. Now 7, we already included over there, so we don't have to write it twice. So I'm just going to say 4 is the last one. So there's the range right there. Those are the range number. Is it a function? Well, it's a function if the x's don't repeat, you guys. I don't see any x's repeating. It's okay for the y's to repeat. Here the 7 and the 7 repeats, but for it to be a function, each domain gives me only one range. Okay, so -7 only gets me 7. -3 only gets me 4. This domain only gets me that one, and that one only. So you just can't have the x's repeating. So yes, it's a function because each domain gives only one range. Or you just check it out and see that no x's repeat. Okay, so this says use the vertical line test to determine if each is a function. Okay, so the vertical line test says this is not a function because right here, you guys, it's intersecting the graph in more than one spot. It's intersecting it right there and right there, so it's not a function. Anywhere I drag that vertical line through tells me is it a function or not. So right there, no, it's intersecting more than one, so not a function. How about here? No, because it intersects in two spots. How about here? No, this line right here intersects it in infinitely many spots, all on this line that goes straight up and down. This one's the only function. That line, that graph only hits that line in at most one spot. So no, yes. Okay. All right. So write an algebraic expression that represents each situation. Okay. So the product means multiply. The product of 7 and, so 7 times the difference. So the difference of a number is going to be like x or n or something and 5. So x minus 5 times 7, something like that. There's that. And there's that. Excuse me. Quotient means division or fraction. Quotient of 7 times a number, so 7x and 12, so 7x over 12. Okay, 5 more than 23 times a number. Okay, so 5 more than means something plus 5. 23 times number means 23x or 23n. Okay, 17 less than 25 times a number. Okay, well 25 times a number is 25x, and 17 less than that means minus 17. Okay, all right, nice and easy. So write a rule for the nth term of the arithmetic sequence. Okay, so our arithmetic sequence formula is that right there. Okay, let's explain this again. It's been a while since we've done this. This means my nth term, a sub n. I forgot if our book calls it t sub n, or I forgot, or f of n. I forgot what they call it. This says my first term. which is that right there. Okay, D is the common difference. How much does it go up by? So from negative 8 to negative 1, negative 1 to 5, and 5 to 11. Okay, so we just got to see how much these guys go up. All right, whoops, that's supposed to be, sorry, this should be in, sorry, my bad, golly, okay, that should be a negative 7, okay, sorry. So let's keep that in mind. That should be a negative 7. I'm going to have to change that through the rest of this, okay? And then from negative 1 to 5, okay, this is going to be plus 6 right here. I'm going to change my answer too. So sorry, I made a mistake on this. I didn't catch it until right now. So check this out. It goes up plus 6 plus 6. So we need to know the first term, which in this case is negative 7, and we need to know what's the common difference. It's 6. So we'll plug in negative 7 there and 6 there. Sorry, let me go through and fix this. Because I'm teaching this to my class in a couple of days. That's negative 7. I wish I could copy and paste. It'll take out those arrows right there, so I just can't right there. So I'm sorry. I hope you guys are okay with that, and please forgive me. Negative 7. I make mistakes constantly, as my students will tell me. Okay, so D equals 6, okay, and we know that our first term is negative 7. Sorry. Let's put that in there. So it's just going to change my answer just a little bit. Again, sorry. Sorry, my colleagues also, because they sometimes watch this. So I'm going to change this to negative 7. I'm going to change these red guys to negative 7 because my arithmetic was off at the beginning because I'm getting old. Anyway, and then we're just distribute this 6 through. Okay, so now that my next step is to clean it up and distribute this 6 through right here. So 6 times n, 6 times negative 1. So when I do that, I get that right there. Sorry, got to do the 7 again. And the 7 here. Patient, you guys. Some of you guys like it when I make mistakes, so I got to go slower in the videos. Got to go slower in class too when I do this, and some kiddos like that. Okay, and then I'm going to combine all the like terms. Okay, so right here, negative 7 minus 6 is going to be negative 13. So I'm going to call it 6n minus 13. Okay, so there it is, right there, 6n minus 13. All right, let me fix that. Almost done. Sorry, that actually, before I built this, you guys, this took me 4 hours to make. I know, I'm not, you guys don't care. I'm just telling you, it just takes a long time to do this, you guys. So anyways, hang in there with me. Please be patient. Okay, next one. All right, so use the rule in number 19 to find the 100th term. Okay, golly, I got to do this one more time. Okay, so this would have been 13, sorry, negative 7, and I didn't even copy and paste. Maybe I'll have to do that. I hope you guys don't mind. Sorry, and I know this video is taking a long time. Sorry. All right, so I'm going to do 6n minus 13. So 6n minus 13 is going to be 6 times 100, which is 600, minus 13 is going to be 687. Okay. All right, or 587. Sorry, 587. Okay. All right, I should be good after that. Hopefully I didn't make some other mistakes. All right, so here's our arithmetic sequence. Find the 50th term. So what I'm going to do is find the nth term formula. So there it is, plus 7, plus 7, plus 7. Yeah, looks good so far. Okay, the first term is that negative 3. And then let's put the 7 through the parentheses. So I get 7n minus 10. Now once you got the formula, we can plug in 50. So 7 times 5 is 35. So 7 times 50 is 350. So minus 10 is 340. Okay, all right, let's do this one here. So find the slope of the line that has equation there, okay? So, whoops, I kind of gave it away right there. If it's in that form right there, let me take that out of there. I'm just trying to be proactive for when I teach this lesson in class. Okay, right here, you guys, if it's in that form, standard form, then your slope is always ax plus by equals c, okay? Let me grab an arrow. Oops, I don't want to do that right there. Ax plus by equals c. Sorry. I think I have it all squared away. So the opposite this one over this one. So our slope is always opposite the number in front of x. So the number in front of x is -3. So opposite that's going to be +3 over 7. So we don't have to worry about the 10. The slope is going to be 3/7 right there. Okay, so I want to copy that so I can use that again. Okay, almost done, you guys. All right, so find the slope of this line right here. Okay, so here what I'm going to do, I think is what I did put this lesson together a few days ago, is I'm going to solve for y and get it in slope-intercept form, y equals mx plus b. All right, so I'm going to take away 2x and subtract 7 on both sides. Let's see, did I do that? I did. Okay, now I don't want negative y, I want positive y. So I'm going to divide by -1, -1, -1, and all that means is change the sign to positive y to -3x to +9. And once we do that, then there's your slope. It's at -3 right there, okay? Almost done. Okay, find the slope of these lines. Okay, so what I'm going to do on these guys is just do rise over run. So here's a point. It goes up 1, 2, 3, 4 over 1. The slope of that guy is 4. Okay? The slope of any horizontal line, you guys, here's a horizontal line right there. The slope of any horizontal line is 0. Okay? And then finally, the slope of this line is going down, so it's negative. It goes down 1, 2, 3, 4, 5. -5 over 4 looks like. So -5 over 4 is the slope of that guy right there. Okay? All right, let's graph these guys. Okay, so what I'm going to do is first plot this point right here. I'm going to plot -1 right there. Okay, and then so let's do that. So there it is right there. And then from there, I'm going to use this slope. I highlighted it in blue, so I'll go up 5 over 2. So from here, up 5 over 2, put another point. Once I do that, then I just get a straight edge, connect them up, and there we go. All right, this one's in standard form, so when it's in standard form, I let x be 0 and make this guy go away. Solve for this. So -2y equals 10, y equals -5. Okay, so when x equals 0, y equals -5. When y equals 0, I can cover up the 2y, so that pretend like that's not there, and we're left with 5x equals 10, so 5 goes into 10 2 times. So when I do that and then connect them up, there it is right there. All right, you guys, I'll have hopefully worksheet number 3 up in a couple days. Take care. Sorry for the long video.